So there's my Twitter, my website, so feel free to follow and just contact me just to chat on things. Today I want to talk about augmented reality, and specifically we'll be building several apps in AR. So my question is, why AR is the future? And if you think about that, basically it's kind of reality 2.0 version. The question that I also ask usually when it started and how it started. So let me just ask you, when do you think the first year when AR was mentioned? Just yell it out. Yeah, mentioned. That's the tricky question. So it was 1901. Basically, it was the book by L. Frank Brown, The Master Key, and the book mentioned some kind of glasses. We're still not there. It was mentioned in the book. So there was glasses that would kind of character type above every person the main character saw on his way. And that was basically the first AR mentioned. It wasn't called AR back then. But then 50 years later, it continues to Sensorama of Morton Heilig, and it was a huge machine that you stick your head inside, you hope you're not fried like in a microwave, and you see things, not necessarily because of AR, maybe frequency, I don't know. Then in '68, there was Sword of Damocles, which is kind of VR AR headset that was hanging above the person. And that's why it was called Sword of Damocles. It weighed 2 tons, and if it falls, person dies. So basically, that's the idea of the name. Then in '82, there was AR for weather broadcasters, and it just continues to virtual pictures and first markers. This is actually the really important point. In AR, there is a concept of markers. When you have an image or some kind of visual representation of anything that you can scan with the AR app, or if it's web AR or anything like that, and it basically renders 3D content on this marker. So first markers were in 1996, and it was called Cybercode. Then NASA developed AR for their dashboards, for their fancy planes and shuttles and stuff like that. Then we had iTap, which was kind of predecessor of Google Glass. Then we had AR used by BMW, and just goes on. 2010 Kinect, Google Glass. Again, markers, sorry, wrong slide. Yeah, and in 2013, it was also an important point. AR, people understand that AR is useful in manufacturing process. So instead of looking, for example, at manuals, people see these manuals in front of them. And, well, they do that instead of learning these manuals. But it helps. It helps QA process. It helps analyzing things. So in 2016, investment in AR and VR thing reaches 1.1 billion. And if you look at market analysis, it will get much more than that. Don't remember exact numbers, but it just grows exponentially. In 2016, Microsoft HoloLens was released, and Meta 2. This is like mixed reality headsets. Pokemon Go. 17 was ARKit and ARCore. And this brings us to the point where we're now. Yeah, and Magic Leap. Magic Leap is the latest thing. So with ARKit and ARCore, and we will use today ARKit and ARCore, we actually can use our phones. We don't need fancy glasses. We don't need to spend tons of dollars on these glasses to buy them. We can use our phone, and like every latest phone has this feature. So the question is why we are not developing AR apps. And I put some pictures for you. So this is Sensorama. And I was not kidding about sticking your head in the machine. This was the Sword of Damocles, and you can imagine how much it weighed. And yeah, it was several. That was the first, the prototype before Google Glass, like iTap, digital eyeglass. And imagine somebody walks on the street like that. Not pleasant, right? HoloLens, Meta, and that's how it's advertised. That's how it actually looks like. So we are not still there in terms of glasses, AR glasses, but we will be in several years. And HoloLens actually is used right now for several medical applications for like scanning things. Like here you have an indicator for higher radiation dose. It's pretty helpful. And this is the weirdness of Magic Leap. And this was that. I don't know, haven't tried that. If you try Magic Leap, tell me if it really feels like that. I doubt so. So when we were young, yeah, and now our moms told us not to sit in front of TV, and somehow now we just stick them on our face, and everything's supposed to be fine. Hopefully, we will know at some point. And AR can be really awkward at some point, because like searching for Pokemons can lead you to, yeah. So the question is how we can use AR today, and for what? The main question is for what we want to use it, because lots of people think about AR as like a gimmicky thing that you can add to your app. Well, it's partially true, but not only that. You can use AR, for example, for retail, while previewing products before buying. IKEA app has that. Wayfair app has that. You can search for a sofa, and then you can just render it in your room and see if it fits. You can get deals based on physical markers, get additional info about products, and we are all in social networking world, so we can share our product images with friends and ask them if this sofa fits home or something like that. And these apps look like that. It's not something that will be in the future. It's already there. A bunch of apps that looks like that. And you have various sales. And yeah, eventually it will bring us more ads. AR for games, well, that was the first type of AR that people started to use. So to interact with the digital world and leverage physical environment. Pokemon Go is the great example of that. Walking down the street, hoping not getting hit by a car while looking for Pokemons. It's much more addictive, and social sharing is easier. So if you compare that with VR, for example, putting headset, having setup at home, this is fairly complex. But if you have your phone in the pocket and you pull it out, you have a AR app, it's really simple. So one of the best games, in my opinion, is like card games or board games that you can scan with AR and see these various interactive content on top of that. But it doesn't stop only there. It goes beyond that. So like having like a game like that in the real world, it's kind of cool. And probably you've seen several stores you can buy like a toy gun, and you put your phone on the gun, you can shoot monsters in the AR world. It's kind of everywhere right now. AR for manufacturing is used for getting valuable information, for getting instructional videos, or it gives you various sets of tools. For example, you can measure things, not in a scale of several millimeters, but in a scale of like several meters. It works pretty well. Even several centimeters, it works pretty well. And it can give you visual clues what you need to do with that or this machine. And location-based AR. It's getting us into a point we can get information from intersection between geolocation and analysis of our physical environment, of these markers out there, and basically it kind of intersects everything into AR. For example, navigation AR apps inside airports. You can pull your phone, look at your phone, a camera at your phone, so you're not distracted. You're looking through the camera at the real world, and you see arrows where to go in that specific venue or airport or whatever. And yeah, everything will lead to ads at some point, so we'll get something like this. Hopefully, there will be ad blocker. Actually, like I think a company that will make ad blocker for AR will make a fairly good amount of money on that. So the question is how we can get started with actual coding. So there are several things we can use, and I'm talking specifically for right now because you can do AR on web too. There's Web AR API. For apps, we can use React Native ARKit or React Native ARCore. These are wrapper libraries for ARKit and ARCore, but they will not maintain for half a year. So I would not choose them for production, no, maybe for experimenting, stuff like that. There is Unity 3D on Unreal game engines, which give you really good plugins for using ARKit or using ARCore. The problem is when you want to develop your app, you feel more in the world of developing games. So you need to learn new tools such as Unity, such as Unreal. If you're an app developer or if you're a web developer, you can be completely lost there because totally different concepts. And there is a library called Vero React by a company called Vero Media. So what they did that's the logo. What they did a wrapper on top of ARKit and ARCore, and basically they use native APIs to get us into AR world. And the cool thing, they consolidate both AR and VR, so you can create both. They have sort of API key, which is free for everyone. You just sign and you get your API key. The library itself is available on GitHub, so you can look through the code. So it has various things. You have like surface recognition and 3D tracking and particle effects and whatnot. And actually, it also supports latest features of ARKit 2, which is pretty amazing. I will show you today if my demo will work. I will show you today how it's new features of ARKit 2 can be used. So how to get started is probably the most annoying title you already see third time today. So you get your Vero API key, you install CLI, and you init your app. Then you will have an app based on, so it's React Native app, and Vero kind of adds different libraries on top of that. So basically, you develop as you develop regular React Native app. So yeah, let's see how it looks like. And I really hope that it will work. Yeah. Can I get more light if it's possible? Because if it's not, we'll deal with that somehow. Okay, so it's already, you see particle effects. So, and you see some kind of text floating. So I know I will look awkward walking on the stage trying to scan things. And you see this rectangular, like a quad on the surface. It means it recognizes the surface, and I can actually render 3D content on the surface. So I can walk around. And you see, I see shadow. These are all of you. And yeah, this is AR. And it uses ARKit. So the model is like FBX model. And I'll try to load something. Yeah, it worked. So there's a window that I will put over here. So this is called a portal. Wish me luck, I'm going to another world. But that's not only it. I can look into the real world from this. Actually, it's a picture of Wakanda, if you've seen Black Panther, so that's how it looks like. So I will probably get faster back because the portal can close and leave me out there. Yeah, and that's how AR looks like. And let's see how it looks like in terms of code. So the basic anatomy of our app is such as this. So we have render function, and we have several navigation types. So we can get VR navigator, or we can get AR navigator. That's how we can switch between different experience, whether it's VR or it's AR. And I told you that framework supports both of them. When you get this navigator, you have a component called Vero AR Scene Navigator, and it can get several AR scenes. Consider you have an AR game and you have several scenes and several setups for AR. You totally can specify several scenes and use them. Our AR scene is basically based on several components. So we have AR scene as a wrapping component. Think about that as Vue in not the framework, a Vue as like React Native Vue. How much people use React Native here? Cool. So the ones that haven't used, Vue is like a container thing. So you can, when I say like Vue, stuff like that, you can think about that as div on the web, basically. It's more complex than that, but in a nutshell. So we have lights. You see we have Vero directional light, and we have several like direction where it comes from, and Vero text, and AR plane selector. So let's just break it down to a component. So Vero AR scene, wraps scene, we set our lights, we position our UI, and we have some kind of helpers. In this time, we have a helper for selecting this surface. And this time, before continuing to the code, let's talk about coordinate systems. Vero uses right-handed coordinate system. What does it mean? If I take my right hand and point at me like that, my Y will be vertical, X will point to the right, and Z will point towards myself. Meaning, if I want to position something in front of the user, I will position on -Z axis. And if you look at this code, you will see that directions and a bunch of things getting 3 values. So that's how you basically position things. So positive Z, X direction, and axis direction is changed when you apply rotation. So think about that. You have, these are axes. If you apply rotation, axes change, and you need to think about how you position things now. And yeah, there is a thumb rule. So if you take your hand like that and thumb points towards the direction of the axis plus direction of the axis, the positive rotation will be along your fingers. So there is a thumb rule. To position our UI, we actually can use Flexbox. We have Vero Flex View. So this inside this view, you can use Flexbox properties for position elements, which is super cool. You position things in AR with the Flexbox. Now let's get to next demo. Let's talk about lights and materials a little bit. I have here, this is a Unity 3D project. It's just visual thing to show you. So why do I need to create lights with the AR app? So let me show you how it looks like. So this is like flat scene without any lights, maybe a little bit of lights here. The directional light component that you've seen in Vero is kind of similar if I enable directional light here in Unity. So you see, you get more inside how scene looks like. You have various textures, have various normal maps. We'll talk about them in a bit. And there are various lights. So we have directional light, we have spotlight, which look like this, and we have various points light. So let me just select maybe all of them. And you see we have like subtle red glow on the scene. So the same you can do with Vero. So you basically use directional light, spotlight. Names are the same. The only change is instead of point light, you will use OmniLight. But the idea is the same. There is a point, and light will go to every direction from that. And you have a bunch of properties. For example, for spotlight, you can basically you have the angle, the inner angle, and the outer angle. You configure your light accordingly. And we also have ambient light, which is a light that fills the whole scene. So if you want all the scene to be like bluish color, you can just use ambient light. And in terms of materials, I can, like for example, in Unity, have things. For example, I added material here. So it has texture, and it's not a just gray cube. It has its own properties. So in Vero, materials are done with this helper function. You call create materials, and you add a diffuse color in this specific example, and different lighting model. So lighting model is a mathematical calculation of how light will bump from the surface. So there are several light models, and you can read about them at their docs, or just Google light models in any 3D development. But basically the same idea. They use Blinn, Phong, Custom, and another one I keep forgetting. So there are 4 light models. And in addition to that, you can add textures. And to pass these materials, you just pass them to materials property. As an array, you can have several materials. And textures are of 3 types. If you use normal shading model, this is our monster. This is how it actually looks like. So diffuse texture is basically the color that is distributed along the surface of 3D mesh of this monster. Normal map is basically the how the light will bump from the surface, and how you will see various curves in the mesh while they are not there. And it's really optimized thing to render some complex 3D model instead of changing the actual 3D mesh, just rendering different shader. So Vero supports regular shading model and also supports physical-based rendering, which I haven't put here in the slide because it's topical on itself. It's like 5-6 different textures, and it gives you like it has a self-descriptive name. It gives you like physical-based rendering. 3D models that you can use are OBG, which is a standard for 3D models. VRX, which you probably, how much of you have ever dealt with 3D modeling, development, or anything? Cool. So you probably heard about FBX models. So FBX models are used everywhere. It's like a standard. So VRX files are files created by running this script, and they basically optimized FBX model to be loaded for mobile in more optimized way. It converts FBX to binary format and connects it to textures that exist on disk. And like the new thing, it's called GLTF files, which is a new standard for 3D models. Basically, it's a binary set of textures and JSON. Yeah, this is without shaders and textures. How to create our 3D models? We can create them with Vero 3D object, and we basically pass source, and we pass several resources. We can either parse material file if we use OBJ, and then it will be rendered automatically, or we can specify our own resources. And for example, here I have Vero Quad, which I used specifically for this monster for rendering shadow. So I took the quad, which is rendered vertically, rotated it 90 degrees, minus 90 degrees. It was on the surface, and then it got AR shadow receiver prop, meaning you've seen shadow of the monster there. And the Vero node is a kind of empty component that wraps. If you want to group things without like starting and just to group inside, you, for example, have 5 models, you want to group them and move them around, you can group them with the Vero node. Additional cool thing, you've seen that on the monster, he was moving and he was like in idle animation. So you can use skeletal animations, in addition to basic animations, you can define them, rotations, stuff like that. But skeletal animations is a pretty huge thing for using them with AR, and it's the necessary thing. You want essentially your models to be animated. And yeah, this is for rendering shadows. So how do you detect AR planes? You can use Vero AR plane, and it will basically have some kind of anchor ID, and we will have on plane selected. I haven't put it here, but we'll have on plane selected prop callback that, and then you can basically store this anchor ID and reference it later. It will be you will know that later on this surface is that recognized surface. But it's a repetitive thing that we keep doing. We need this UI or with a gray quad for recognizing surface. It's kind of standard. So there is a helper component called Vero AR plane selector, and that's what recognizes the surface. Basically, we have a component called portal scene, and we have Vero portal. So whatever we wrap inside Vero portal scene, Vero portal, sorry, that will be the object that will correspond for the 3D frame around this portal. So here I use 3D objects, similar as I used with Monster, and providing it with wood frame and several textures. For additional component that Vero portal is waiting for is Vero 360 image, and that was for the 360 image of Wakanda. And that's about it. That's the portal. So if experience look cool, it's super easy to create. Yeah, I have here on drag callback, and you saw the fact I dragged this portal and put them on scene. So I can actually drag any object or interact with any object in an AR world. So we also have particles. And particles are a fairly complex thing, but it's important to know that we can do them. We have some kind of emitters here that we set, and these emitters produce several particles of specific image. And we have a bunch of things that we can define on spawn behavior. So it's a cool thing. We can do also particles. And there is another demo I want to show you. I promised ARKit 2 features, right? So in ARKit 2, they added continuous image tracking. So I hope it will work with this light setup, but it won't. Let's see. Oh, yeah. Tracking is kind of bad here, so maybe like this. Yeah. And I can move this card around. And yeah, it's a bit laggy because it's fairly dark here, but you got the idea. And all the code is open source. You can check the code and how it's created and stuff like that. So the question is where to get 3D stuff, and that's the most important question people ask. Like, cool 3D models, textures. Where do I get this stuff? Like, I won't pay 3D artists for like my home projects and like things to play with. So there's Unity Asset Store, which has lots of free stuff and have lots of also paid stuff. There is Turbo Squid, Sketchfab. These three sites, like most of the things are paid there, but there are some free things. Mixamo is a really cool website. It's free for everyone who has a Adobe account. And basically, it gives you an ability. It has, I think, around 20 different models, and this monster was from this website. The most important thing in 3D modeling and animation, there is a process called rigging, when you take your model and you put the joints of model bones, and then you can animate them. So even if you download free model from somewhere which is not rigged, you can upload it to this website. It will do auto-rigging for you and has huge library of animations that you can choose from. So it's a really cool one. You can model yourself in Blender. For textures, you can use Substance Source, also cool, cool place to get textures. And the question is when to develop AR apps with Vero. I would say when it's an app and not a full-blown AR game. Probably if it's full-blown AR game, it will be probably easy to develop in Unity 3D or Unreal. But for casual games, actually, you can do that in Vero. And I actually this week, I will release a blog post of how it's done. How I created kind of Tetris game in AR. And if you check my Twitch recordings, and the last Sunday I recorded the whole thing, like how we do this from scratch. So my like the takeaway from this talk: start building AR apps today. It can contribute to the business. You maybe have next really cool idea. And thanks for having me here. This is my Twitter and website. And thanks.